Hello everyone, welcome to my channel. Myself Vignesh Anand. In this video, we are going to see about the motors and the types of motors and the basic working functions. So, normally, a motor, electric motor, is a device which converts a electrical energy into a mechanical energy. So, it is mainly used in your most of the applications in which movement rotations are being carried out, and it works on a principle of Faraday's law of induction, which means the current carrying conductor which produces a magnetic field around it. A current carrying conductor is placed perpendicular to the magnetic field which produces a torque in it. So this is how the motor works and its principle. This is just for your understanding. Every motor has a two essential parts, which is your field winding and the armature winding. So the main function of a field winding is to produce the fixed magnetic field, which means the magnetic field will be produced in a field winding, whereas the armature winding looks like a conductor which is arranged within the magnetic field, which means the armature winding will be arranged within or inside your magnetic field. So because of this magnetic field, the armature winding uses the energy to generate an adequate torque in it. So the torque which makes the shafts to rotate, and thus the electrical energy is converted into a mechanical energy. So next, coming up to the topic types, the motors is mainly classified into three types. One is your AC motor, second one is your DC motor, and third is your special motors. So the AC motor is further classified into a subclasses as a synchronous motor and asynchronous motors and commutator motors. So this synchronous motor is subdivided into a uh, excited synchronous motor, single phase synchronous motor, and three phase synchronous motors. And unexcited synchronous motor is subdivided into two types: reluctance motor and hysteresis motor. Then asynchronous motor are your induction type of motors. Then it is further subdivided into a squirrel cage induction motor, slip ring or wound rotation induction motor, capacitor start induction motor, capacitor run and capacitor start induction motors. Then the commutator motors. The commutator motor is subdivided into a AC series motor, then AC compensated motor, then repulsion motor, and repulsion start induction run motors. So this is all the main classification of your AC motors. Then DC motors. DC motor is further classified into a uh, brushed DC motor and brushless and coreless DC motors. So the brushed DC motor is subdivided into a separately excited DC motors, separately excited DC motor, then self-excited DC motors, then series wound DC motor, then shunt wound DC motors, and then compound wound DC motors, and permanent magnet DC motors. Then special motors. Special motors are servo motors, direct drive motor, then linear motors, stepper motors, and universal motors. So these are all the special motors. This is subdivisions of each types. Just you can go through it. Next we will see the basic working principle of each motors. First, AC motor. The AC motor basic working principles are that the rotation or the rotating magnetic field generated by the stator winding when an alternating current is passed through it. So the rotor, which having its own magnetic field, follows the RMF and starts rotations. So this is your working principle of AC motor. Then synchronous motor. So In this motor, which has a constant speed called synchronous speed, that only depends on the frequency of your supply current. So the speed of such a electric device only varies with the variation in the supply frequency and remains constant upon the varying loads. So in here the synchronous motor, the motor is having a constant speed, and it can be varied, the speed can be varied upon with your frequency of your current, but anyhow the speed will not varies with your load variations. Next is your excited synchronous motor. This excited synchronous motor requires a DC excitation, which means the DC excitation means the rotor has a separate DC supply to generate its own magnetic field. So this is the difference between your normal synchronous motor and excited synchronous motor. Then asynchronous motor. So this type of AC motor that never runs at a synchronous speed. So the rotor rotates in always less than the synchronous speed, and it does not require any separate rotor excitations. So it will works like a normal synchronous motor, but anyhow the synchronous speed will not be attained in by your rotor. Then commutator motor. So this type of AC motor that utilizes the commutator and brush assembly to supply power to its rotor. Such a electric motor have a wound type rotors. So in here the commutator and brushes assembly to supply a power to its rotor. So it has a separate assembly set for your rotor supplies. Next is your induction motor, which means your asynchronous motor. uh, it works on a principle of electromagnetic induction between the stator and the rotor. So the revolving magnetic flux induces a current in the rotor due to electromagnetic induction, which produces a torque in the rotor. This is the working of your induction motor. Then coming up to DC motor, the DC motor which uses the DC supply for producing the magnetic field, and it works on a principle of Fleming left hand rule. So a current carrying conductor inside a magnetic field experiences a force of thrust which mutually perpendicular to each other. So the DC motor mainly works on a principle of Fleming left hand rule. Next is your coreless or ironless DC motor. So this motor, as in the name itself, you can easily able to know that there is no lamination or laminated core iron cores in it. So the rotor winding is wound in a skewed or a honeycomb shape to form a self-supporting hollow cage, often uh, using XOPs. The rotor made up of a permanent magnet sits in the hollow rotors. So this is the working of your coreless or ironless DC motor. Next servo motor. So the servo motor is a special motors. So in this motor, which is mainly used for your pulling or a pushing or a lifting a object for a specific angles. So this is also a common basic working like a electromagnetic induction principle only, but it is mainly used for your pulling or lifting of an object for a particular angle or a particular positions. Next coming up to the stepper motor. So the stepper motor, which is having a brushless DC motor whose full rotation is divided into a number of equal steps. So such a motor rotates in a fixed degree or fixed angle instead of rotating continuously. This type of stepper motors are mostly used in our solar panels, where the panels need to be moved according to the sunlight. So automatically it will move for a particular degree or a particular angle. It will not rotate fully, or it will not rotate continuously. These are all the basics of your motor working principles. Hope you understand. I think so. See you in next video. Have a nice day. நன்றி, வணக்கம்.